All right, today we're going to talk about a new smart contract language called Compact, and it was really built from the ground up for one big reason: privacy. The goal here is to completely change how we think about and handle secrets on the blockchain. So let's dive in and see how it works.
I mean, really think about that for a second. So much of what we do in our digital lives involves information we'd rather keep private, right? So what if the actual logic of an application, its very core, was designed to protect your data by default? Well, that is the central question that Compact is trying to answer.
So what is this thing really? Well, for any developers watching, the syntax is going to feel super familiar, a lot like TypeScript. But what's happening underneath the hood, that's a whole different beast. It actually compiles your code into what are called zero-knowledge circuits. A simple way to think about it is this. It's like proving you know a secret password without ever having to actually say the password out loud. That's the magic trick that makes real privacy possible here.
To build these private apps, Compact starts right at the foundation, the data itself. And this brings us to our first really important feature: structs. The best way to think of them is like super strict blueprints for your data. They define exactly what a piece of information is supposed to look like and nothing more.
And here is the key difference, and trust me, this is a big one. If you've ever used JavaScript, you know that objects can hold both data and functions, executable code. But a compact struct, it's pure data, period. It's just a container for information, not code that can run. And this might seem like a small technical detail, but the security implications are absolutely massive.
And the cool thing is, Compact gives you some really powerful blueprints right out of the box. For instance, there's a struct called maybe. It helps you avoid all sorts of common bugs by safely handling data that might not be there. Another one, called either, is perfect for when a value could be one of two different things. These aren't just little conveniences. They're tools to help you build stronger, more predictable code right from the get-go.
So why does this matter so much? Well, by forcing this separation of data from code at the most basic level, you just wipe out an entire category of potential bugs and security holes. You're creating these predictable, totally safe containers for information, which is exactly what you need when you're building high-stakes applications.
Okay, so we have these secure data blueprints, but how do we organize everything when a project gets big and complicated? Well, that brings us to modules. Compact uses them to structure code, and a fantastic way to think about it is like using prefabricated sections to build a house. It's just faster, cleaner, and way, way easier to manage.
And the process itself is really simple, but also really powerful. You just define your logic inside a module, you export only the specific pieces you need other parts of the app to see, and then you import it wherever you need it. This whole system prevents those annoying name clashes that can cause some of the most subtle, hard-to-find bugs in big projects.
And we can see this approach working in the real world. Just look at the work from OpenZeppelin, a team that's famous for creating super secure smart contract standards. They've built a token contract using Compact, and its clean, modular design makes it, and I'm quoting them here, a very good starting point for more complex applications. It's basically a perfect example for other developers to follow.
So at the end of the day, what's this all for? It's about building better, more reliable applications. Modules give us code that's just easier to read, easier to test, and easier to reuse. It's basically bringing all the best practices from modern software development into the world of smart contracts.
Okay, now let's get to the main event. The entire reason Compact exists in the first place: privacy. You see, in most systems, privacy feels like an afterthought, something you bolt on later. Here, it's woven right into the fabric of the language itself. The whole idea is that your secrets are safe by default.
But, it's not a magic wand. You have to know the rules of the road. By default, any secret information that you feed into your contract's functions, this technical stuff called circuit arguments and witness data, all of that stays private. But anything that gets written to the public blockchain ledger, well, that becomes visible to everyone. Understanding this dividing line is absolutely critical. And this brings up a really, really important question. If a developer can take private data and write it to a public ledger, how on earth do you stop them from doing it by accident?
Compact's answer is this brilliant little safety feature called explicit disclosure. It's so simple. The compiler just will not let you make private data public by mistake. You literally have to wrap that data in a special function called disclose, which forces you to stop and consciously say, yes, I am absolutely sure I want to reveal this information.
And the big takeaway here is how this one feature completely changes the way you think about privacy. It's no longer something you just hope for.
It's the default state, and you have to deliberately and intentionally break out of it. This builds an incredibly powerful layer of trust and security right into the foundation of any app you build.
All right, for our final big idea, we're going to talk about something that is a radical rethinking of what a token even is. Compact makes a model possible where tokens are no longer trapped inside the smart contracts that made them.
Let's just compare for a second. In the typical Ethereum model, your token balance is really just a number in a big spreadsheet that lives inside a smart contract. You don't really hold the tokens yourself. But on Midnight, using Compact, a contract can create tokens and then actually send them to you. They leave the contract. They become completely independent assets that live directly in your wallet. And the language gives you a whole suite of tools to manage these new kinds of assets. You can mint them, send them out of a contract, explicitly receive them back into a contract, and even merge or burn them. It's a complete lifecycle for a new kind of digital property.
And this right here is the profound part. This model creates what you could call true digital ownership. The assets in your wallet are yours, in the same way that cash in your physical wallet is yours. They're independent of any single application or bank, for that matter.
So let's pull all of these different threads together. We've looked at how Compact handles data, how it organizes code, its approach to privacy, and this new idea of assets. So what does this all add up to? Why does it matter?
It really comes down to these 4 interconnected superpowers. You've got secure data through structs, organized code with modules, intentional privacy as the default setting, and finally, true asset ownership with this native token model. Each one builds on the other, and when you put them all together, they really do represent a major leap forward. And that leaves us with one final thought to really chew on. For years, we've been trying to build privacy on top of systems that are transparent by design. But what happens if you flip that? If you start with privacy as the default foundation, what entirely new categories of applications, businesses, and just human interactions, what suddenly becomes possible? That's the future that Compact is inviting us all to build.